use its own propulsion system to land on the ground again. But the micro adjustments required to do that were just beyond the capability of just computers until the last used its own propulsion system to
and
land
of the things that
on the ground
I
again.
think
But
aided and abetted in allowing this to happen was the commercial space race saying, yeah, we're just going to test this stuff with our own money. We're going to try and get all the federal contracts. But by going solo, we can use technologies that aren't yet space certified and make them space certified along the way. The SLS is using a G3 from the late 90s. And with SpaceX and with the New Shepard, New Glenn series from Blue Origin, they're using the latest processors, CPUs, GPUs to figure everything out as they go. And that is huge.
Yeah, and it was amazing to watch as SpaceX was able to successfully, they had a lot of failures, and then they started to stick the landings, but the landings weren't close. And I saw a video just a couple of days ago showing just a most recent routine landing of a Falcon 9 booster, and it must have been within centimeters of the X where it was supposed to land. It was so precise, so accurate. They have absolutely nailed this. And at this point, I mean, SpaceX is reusing these Falcon 9 boosters more than 10 times.
Yeah.
It's incredible.
And they're able to do that because they have their own stuff they don't mind if they inadvertently blow up. They're testing just how many times you can reuse these boosters by taking the boosters that have been flown more times than they're certified to carry NASA payloads, and they're using them to lift Starlinks. So they have their own commercial case that is paying for them to use experimental technologies.
And so I think they really, in this case, SpaceX is really living the dream of having a space truck.
Yes.
With the Falcon 9. And that was sort of always the hope with the space shuttle. Now, of course, SpaceX isn't the only company in the works. There are some.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, the director of the observatory, and I'm joined tonight by the fabulous Quentin Wayrich, a previous observatory coordinator extraordinaire and a little bit of a DDO expert. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is, in fact, Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then on to Western Worlds, Quirks and Quarks, and Science for the People. Just as a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT for any of you in a different time zone. The York Universe production works in concert with our online public viewing program run by the wonderful Observatory team. This also, of course, means it runs between the hours of 9 to 10 p.m. local Toronto time. You can, in fact, find them right now showing wonderful observatory images. All you have to do is go to our new website. Again, I'm reminding folks this is still somewhat of a new development. The website has moved to yorku.ca/science/observatory, but do not panic. The old site will take you to the new site. So once you get there, follow the links to OPV online public viewing, or just click on any of the Allan Carswell Observatory YouTube links. That will take you straight to the YouTube session. You'll be able to see the images on YouTube Live and join in on their chat, of course. It is a bit cloudy tonight, so we'll see how that goes. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have with our past shows or suggestions you might have for future topics, please send us an email at observe@yorku.ca. And if you are on the social media, you can connect with us on Twitter at York Observatory, Instagram at York U Observatory, and of course Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see that amazing new website. Yes, I'm going to keep saying it, yorku.ca/science/observatory. In the meantime, we are, of course, monitoring the chat room for questions. Our observatory crew is over on YouTube right now, waiting to take your interesting questions and posting pictures. The current weather is a strong chance of ice pellets, so I don't think they'll be able to open up the observatory. You'll probably get some lovely previous images. No promises, but I hear that there was some successful comet viewing just this last weekend. So fingers and toes crossed, we get some of those beautiful images out to you. And in the meantime, of course, all weather aside, we've got a great show lined up for you tonight with all kinds of space and astronomy and history. Before we dive into that, I just thought I'd say, Quentin, how are you doing this evening?
I'm doing great, although I'm a little bit worried about those ice pellets you mentioned. That's going to complicate my drive to work tomorrow, if that's true.
Yes, I agree. The freezing rain and ice pellets do not, I repeat, do not have an observatory recommendation. Bad for cars, bad for astronomers, and bad for telescopes. We did get some wonderfully clear weather on Saturday night / Sunday morning, though. It's been rare clear nights. Gosh, I guess it's usual for Toronto this time of year. But it's been, I think, quite a while since we had a photometrically clear night all the way until sunrise. And that is, in fact, what happened on this last weekend. So I'd just like to send a little observatory shout out. Thank you to Zaina and Sana, who were up at the 1 meter telescope getting beautiful, beautiful imaging of that new comet C2022, even though it is 2023. It's looking like that comet is going to be great. So we'll talk a little bit more about that later on in this show. Just so many interesting things happening in astronomy all the time.
Absolutely.
Yes, and I was just like, well, and speaking of time, maybe this is a good time to do a little time traveling ourselves. As per usual in this show, we like to think about our astronomy in context, and of course that means this week in space and astronomy history. So Quentin, you've got some really interesting items that you've uncovered in the astronomical archives. I absolutely love your first one, so I'm just going to say without any spoilers, why don't you take it away and go back in time for us?
Oh, thank you. This one's really close to my heart, too. So between January 7th and 15th of 1610 is when the Galilean moons were first discovered. So on January 7th, 1610, Galileo pointed his newly improved telescope at Jupiter and was able to resolve 3 additional points of light, which at the time he called stars, and it was lying near it along the ecliptic, which is the plane of the solar system, the plane through which all the planets, as well as the sun and the moon, appear to pass from Earth's perspective. 2 of them were on the east and 1 was on the west. And then when he observed them again on the next day, all 3 were on the west. On January 10th, he was only able to see 2 on the east side. And when he observed Jupiter on the 13th and the 15th, which is 413 years and 1 day ago, he was finally able to observe all 4 of the objects that we now know as the Galilean moons all at once. So these bright points of light were, of course, Io, Callisto, Europa, and Ganymede, the 4 largest moons of Jupiter, which can be seen from Earth using a telescope. And the reason, of course, why he was the number that he was able to see varied is because some of those moons were spending their time in behind the planet. Galileo was able to tell, based on their observed motion, that they were in orbit around Jupiter, and that the satellites with the tighter orbits had shorter orbital periods. This was in keeping with Kepler's laws of planetary motion, which were being published at the same time. And Kepler himself was later able to demonstrate that his third law, could be applied to the orbit of these objects around Jupiter. So this law states that a planet's orbital period squared is proportional to the length of the semi-major axis of its elliptical orbit. That's the length, the long dimension of the ellipse, cubed. You take the semi-major axis and you cube it, and that's proportional to the square of the orbital period. And this was the first evidence we were able to find of objects in orbit around other planets in the solar system. And combined with Galileo's subsequent observations of the phases of Venus, it supported the heliocentric model of the solar system that we, of course, have now come to accept.
Amazing. So much amazing, awesome astronomy in that one area.
Absolutely. You know, the Galilean moons were one of the first objects I had the opportunity to look at the Allan Carswell Observatory, and it was so fascinating. I remember being blown away just realizing that I could see the moons of another planet from Earth. I didn't know that.
Yeah, and it is something that's great if you are starting out in astronomy as a first target, because the way the moons orbit around Jupiter makes them wonderful targets to be able to actually see changes in the solar system. We're used to kind of having the planets be these static, unchanging points of light in the sky. So of course, if you can have that be something that you can see change in real time, it really drives home that this is another planet out there. And it is interesting that, of course, Galileo made this discovery in Europe, as you say, in the 1600s, but other places on Earth had also discovered potentially these moons. And there is some evidence from Chinese historians that basically a moon was discovered around Jupiter as early as 364 BCE.
Wow.
And whether or not at that time they made the connection that it was in orbit around Jupiter is perhaps debatable because of the quality of the records that long ago.
Right.
And so it's said, everything old is new again, and
Absolutely.
it is worth remembering that it's because of the record keeping problems and the problem in communicating your results. A lot of these things were discovered at different times for the first time in different parts of the world, and it just makes astronomy history really, really interesting. Of course, Galileo having a quote-unquote modern telescope did mean that he was able to observe 4 moons. I think you first saw 3 of them, is it what you said?
Yeah.
So
I don't know which 3, obviously, but yes.
And sometime later it was like, yes, there's 4. So it is interesting as technology sort of had that boom, we got more accurate discoveries, but certain things like, of course, the mountains and valleys on the moon and the moons themselves of Jupiter had been proposed in some cases thousands of years earlier in completely other places on the planet, which is just astronomy history is so much fun.
Yeah. It seems like the more we learn about astronomy history, the more we realize how complicated astronomy history is. Because, and it's like this with math history too, I find. Every discovery that gets credited to a certain person, there's always a way to, when you find out more about it, it always seems like there's more to the story than that. It always seems like it's a point of contention about like exactly when this was discovered.
Well, that's human history as well, because the records that survived are not complete, which is always in any area, math, physics, chemistry. I'll go ahead and say chemistry. I'm not a chemist. But yes, absolutely. And Jupiter out there right now, the one thing we can all agree on is that if you do have the technology, a small telescope or good binoculars, you yourself can go out and watch the moons of Jupiter moving around and going across its surface. So you don't have to take our word for it. And actually, Jupiter is up right now. Today is the 16th of January. Oh boy, I've got lost. I almost said July. 16th of January. It is 9:12 p.m. in Toronto. If you are in the Toronto area, Jupiter at the moment is about 17 degrees above the horizon and setting. So it's a nice bright object in the sky. If you've got a clear view towards the west, you can catch it with your binoculars right now. So I'll let everyone run outside and then turn the radios back on. And if you are outside, I'll just go ahead and say, this is an astronomy show. Mars is also up very, very high, almost at zenith. It's actually 70 degrees above the horizon, so it'll be right overhead, bright red object. Always really fun to target. And if you want to hear a little bit of spoilers about that comet, it is super, super low. So you have to have a perfectly clear view, and it's half of a degree above the horizon. So the comet viewing is not good right now.
Can it be seen with the naked eye yet?
No. That's a good question. A lot of people are wondering, when will the comet be visible for people to go and look at? The answer is we don't know. It's getting brighter, and it's not at its closest approach to Earth, so we think it's going to keep on getting brighter. It's about magnitude 6 at the moment, I believe. Don't quote me on that exactly, but it went from magnitude 8 to magnitude 6 within 3 days. So it's getting brighter and brighter as we get closer and closer to its sort of maximum approach to the sun. And of course, at its closest point to Earth, we should get a pretty good show. So February 1st, watch the news, I suppose.
Fingers crossed.
And we'll talk more about the comet as well. I don't want to get us too far sidetracked. We're running around through space and time, going backwards and forwards all over the place. Okay, so I think it's my turn now. So I've got a totally different area that I thought of. I was poking around at space and astronomy history, and I'm actually going to go not nearly far as back as you did, so not to 1610, but only as recently as 1945, January 15th. January 15th of 1945 was very interesting times. We had the Manhattan Project going on here in the Northern Hemisphere, North America in particular. And the Manhattan Project has a lot of interesting things about it. It's not strictly astronomy, but it's very, very, very much physics. And one of the interesting things about nuclear energy is that, of course, it can provide a lot of energy with somewhat less input than you need. So here on Earth, we use fission for things like nuclear power plants, but we knew once we realized what was powering the sun was fusion energy, that there was a lot more energy to be had out of atoms. And so the Manhattan Project was set to try to produce the first nuclear weapons, which is pretty scary stuff. It began pretty modestly in 1939, but ended up going all the way to 130,000 people involved, with about 2 billion at the time. So that's 24 billion in 2021. So more than that now, because the dollars kept going up. But that was a lot of research into the development of atomic bombs. Of course, it's sort of a dark side to physics and astronomy that these bombs were produced and used. But the interesting thing about this particular day in history is that this was the day that they took their first Betatron pictures of a nuclear implosion at Los Alamos Laboratory. And it's something that I think a lot of astronomers don't realize. There's a lot of crossover, of course, in physics and astronomy. You can almost say they're basically the same thing. Just don't tell the physicists, I suppose. But we need physics for astronomy, and of course, in nuclear reactions and nuclear physics, it gets very interesting with the amount of energy created. The betatron is actually not a camera per se. It's a type of particle accelerator. It's essentially kind of a torus-shaped vacuum tube. And then it's got sort of a transformer bolted to it. So if you know a little bit about electronics. So this betatron device allowed them to basically get an image or a sort of I suppose you could say rendering of the implosion, and this actual first betatron of Donald Kirst, who I believe was involved in the project. He was the head of Manhattan Project's G5 group. He actually has his first betatron on display in the Smithsonian National Museum of American History. And it's actually not that scary looking. It's kind of just a wooden box with some kind of railings, sort of rectangular railings stapled to the top, and some sort of little wheel looking thing in the middle. If I've described that probably badly, you should look up the picture. So this is accelerating electrons by magnetic induction. And Donald Kirst was a physicist who was first successful in producing electrons at this very, very, very high energy. And you could actually later on use these as accelerators. It's used in industry, in nuclear physics research, and actually in medicine. It also provides gamma rays for photonuclear studies. So we have now areas of gamma ray astronomy, which came out of this betatron sort of study and this betatron device. And actually, it's interesting is that one of the side benefits of this betatron device was using megavolt electron beams that produce energetic X-rays to irradiate cancer. And it was sort of some of the first successful sort of medical applications. So it's kind of goes all over, because on the one hand, we can see, of course, the Manhattan Project producing nuclear weapons, and on the other hand, we have the betatron being used, or it's theory being used for devices in medicine. This first image that came back, the first betatron image from the Manhattan Project, was something that they had to heavily process. And it's actually pretty interesting because the whole entire research project of the Manhattan Project was highly, highly secret. So a lot of people who were working on it might not even have known what they were working on the time. And they had multiple different groups, research groups. As I say, I am not a Manhattan Project expert, but there are people who actually spend their lives researching exactly these kinds of interesting things. The G5 group, headed by Donald Kirst, of course, of the Betatron, and Seth Nadermeyer, they took their first Betatron pictures at Los Alamos, and at the same time, they were sending a mass spectrometer results into a secret area. And this secret area was housed by, and I'm not kidding, this is what they were called, the Calutron Girls.
Sounds like a name for a band.
It kind of does, because in 1945, the people doing the most programming were women. It was not viewed as a particularly glamorous or well-paid job. So if you wanted programmers and analysts and technicians and computer people, you had women. And so there are some pictures that survived from the lab of the Calutron Girls, who were monitoring in particular the mass spectrometer of the project. And this is actually, you can find some of these online in Manhattan Project archives. And it's actually one of it even goes further in terms of the amount of interesting aspects in this story, just in case you thought I was done. One of the Calitron girls, Gladys Owens, has actually gone on record with a news outlet saying that she did not know what she was involved with until she saw a picture of herself at work being toured in an exhibit 50 years later. So remember, this is 1945. This was happening. We're now in 2023. So she's 50 years out from 1945. She sees a picture of herself at work as a person monitoring the mass spectrometer as a Calitron girl. And she had not even known that she was working on the Manhattan Project because it was that secret. So their whole office was separated from the G5 group. So that's how secret it was at the time. They didn't even tell people. So 50 years later, she found out. It's crazy, interesting times and a very odd time in history, but it's worth remembering. So I just thought everyone would like to know that this was, well, approximately minus 1 day. So January 15th, back in 1945, this time of year, back in 1945, this was when the Calitron girls were monitoring that mass spectrometer, and the Manhattan G5 group got their first picture from the Betatron of the nuclear implosion at Los Alamos. So yeah, a totally different type of astronomy, I'm sure. And this one is so much more recent, but there's still so much we don't know about this event. So we talked about, of course, Galileo and what we don't know about his discoveries and other places on Earth that had viewed Jupiter. But this is already 1945, and there's so much mystery in this project.
Yeah, absolutely. I speaking of things that I'd really like to know more about, can I talk about the next item? I'm really itching for this.
Yes, go for it.
All right. So on January 14th, 2005, was when Huygens landed on Titan. So that was 18 years and 2 days ago. The European Space Agency's Huygens lander successfully parachuted down onto the surface of Titan, which is, of course, Saturn's largest moon. And it beamed data back to Earth for around 90 minutes and provided us with images of the surface of Titan and data about its methane-rich atmosphere. And Huygens, which is of course named after the Dutch astronomer who discovered Titan in 1655, was launched as part of the Cassini mission to Saturn on October 15, 1997. The mission was successful beyond expectations. It involved Cassini-Huygens entering Saturn's orbit in 2004, Huygens separating from Cassini in December of that year, and then being tracked by Cassini as it descended toward Titan prior to its eventual landing. And while on Titan, Huygens used the orbiting Cassini as a radio relay to transmit its signals back to Earth, before Cassini passed out of range and the signal was lost. Cassini continues to gather information about the Saturn system for over a decade after this, performing flybys of several of its moons, performing radio occultation of the rings, and observing the hexagonal cloud pattern at Saturn's North Pole change color over the course of several years in what is believed to be a seasonal effect. In 2017, Cassini performed its grand finale, performing a series of close approaches to Saturn from within the ring system before finally burning up in the atmosphere on September 15th. And this was in order to avoid crashing into one of the moons and contaminating it once the spacecraft was no longer functional. Huygens, however, is most likely still intact on the surface of Titan, but its batteries are long dead. It only had enough battery life to operate independently of Cassini for about 3 hours. So this mission was the first to enter orbit around Saturn, the first to land on an object in the outer solar system, and the first to land on a moon other than our own. And what really intrigues me about this, what really sets my imagination going, is just thinking about this object just sitting on the surface of this alien moon for decades to come, for centuries to come. Deactivated, unable to send data back to Earth, even if it did have battery life. But just who knows, like what kind of crazy landscapes are surrounding the Huygens craft, because it was able to send information only really about like the local area in its vicinity. It's just, I don't know, it just boggles my mind to think about this thing that we made here on Earth sitting for perpetuity on another world like that.
Absolutely. And it is, of course, extra captivating because this is the only thing that has landed on Titan. So Titan being a somewhat solid surface, I'd say somewhat, it does have lakes, permanent liquid hydrocarbon lakes. We think they're permanent anyways. Um, and now we have, as you say, this object which is sitting there, and if there is anything that can live on that incredibly cold, strange little moon with an atmosphere, it might someday find the little craft that we sent. And it
That'll
is
be a puzzle for the ages, huh?
Yeah, it would be a real puzzle, because if this is the only thing we ever send to Titan, that would be kind of sad, but it would also make it really mysterious for anybody who found it. Because they would just be like, "What, is this it?" We didn't put a golden record or anything on that. But it does have, of course, lakes and seas, in theory. So who knows? Maybe maybe there's periodic melting of some of these methane, incredibly cold things, and maybe it'll take take sail and become a little sailboat, and we'll find it in 40 years in a completely different spot.
I don't know. It's crazy to think about, though. I just love thinking about stuff like that.
Absolutely. And of course, Titan is a 100% recommended object, and it's such an interesting mission in so many ways, because of course Saturn, Neptune, Uranus are all so, I mean, I wouldn't say criminally, but they're so underexplored.
Absolutely.
There's so much that we've learned from the very, very few things that have ever been there. But it's just like there's so much to discover, and you can just taste the discoveries waiting to be found. Especially when you have something as interesting as Titan with actual lakes. And you mentioned it launched around 1997 or so.
I believe yes, I believe it was 1997.
Yes, and it's worth noting that getting to Saturn is not easy. So it launched in 1997. And it took 6 years to get there. So they had to start planning this mission back in the 80s.
Oh.
And we got, of course, we started getting amazing data when Huygens launched by parachute in 2005. And so this is another great example of long-term planning being so important in space travel, because what we do now and what we approve now determines what we're going to be able to find in the next 20, 30, 40 years from now, when that thing actually does get to Neptune, or well, I can hope it'll get to Neptune. Something will get to Neptune. But yeah, it's long-term planning, and for such a reward. 100% recommend watching all of those images. Everything from Cassini-Huygens mission is amazing. All right, so at Cassini and Huygens, and oh yes, Quentin.
Oh, I was just gonna say, like, Titan is larger than Mercury, right? It's a moon that's larger than a planet in our solar system. There's so little of it that we've been able to really explore, because it's also, correct me if I'm wrong, it's got a very thick atmosphere.
Yes.
So it's very difficult to see the surface unless you do what we did with Huygens, and you send a lander down.
Yeah, exactly. And it is the only real atmosphere rocky planet thing that we have other than Earth, right? So Mercury, no atmosphere to speak of. Venus, way too much atmosphere. Earth is just right. Mars has almost nothing, but then you get Jupiter, Saturn, and Neptune. Those are all gas giants.
Nothing but atmosphere.
Nothing but atmosphere. So if you want something that's actually got I wouldn't say livable because the temperature is so cold, but an atmosphere that could sustain an ecosystem, which it definitely has, then you're really looking at Titan. Everything else is, rock and then space, or ice and then space. Great stuff, though.
Well, speaking of potentially sustaining, speaking of objects that we talk about the potential for sustaining ecosystems on, Elena, do you want to go to the next item?
Yes, I think this actually, I did mention Mars, not much of an atmosphere, nothing really there. It does actually have an atmosphere, and I am actually a pretty huge Mars fan. It has a little bit of a cycle in terms of its dust storms that come through, and it does actually deposit ice and snow onto its poles at regular intervals. So Mars is not as bad as I made it sound just there, actually. And in 2013, so again, I'm sort of following my trend of picking things that are kind of recent. In 2013, in January 19th or 18th, depending on how you count the discovery as either when they got it or when they sort of first put out the first announcement, calcium deposits were discovered on Mars by NASA's Curiosity rover. So NASA's Curiosity rover has been an amazing success. The Curiosity itself was a really, really exciting rover. And the rover was investigating parts of the Yellowknife Bay to look for drill activity on drill activity spots that they could put in for for the Mars Science Laboratory. And what they actually found was they had this really interesting set of features. And sedimentary rocks, pebbles, cracks, nodules, veins, and they saw some vein features which were bright white material, which they could then send over to the Curiosity, and where they sort of place the material into a little container. And as I recall, what they do is they sort of put powder into what was called the SAM, and they do actually provide an analysis of it. So the Curiosity rover has, as I say, been an amazing mission, and the discovery of calcium was really interesting in a couple different ways, because we're used to discovering rocks and mineral deposits here on Earth, but not so much so on Mars. You tend to get, sort of basaltic rock and, other kinds of rock, infrared reflecting or not. But what kinds of mineral deposits could have been laid down? Well, that gets into a little bit of the history of Mars, because as we spend more time looking at Mars, and this has had no shortage of missions at all, which I'm actually very happy about. One of the questions is, if you could travel back in time, what would Mars look like 3.5 billion years ago, when it would have had a lot of water on the surface? What would it have been like? And what kinds of sediment and deposits would it have been able to create? So we think that much like on Earth, there would have been sedimentary buildup by water and wind. And then once that layer and layer and layer gets built up, wind can carve out little passageways into that layered rock, which actually Curiosity did climb past some of those. So it's really, really interesting place to study, and finding, as I say, calcium deposits. This is, things like hydrated calcium sulfate that they found inside broken fragments of other rocks that they had analyzed. And if you want to find out more, the Curiosity rover has a lot of great pages over on NASA. There's a lot of wonderful updates from Curiosity. It's actually still got an active homepage, and it is the car-sized rover. So this, in case you're wondering, this was the sort of more like small car, compact car. We're not talking SUV here. It was launched in 2011, which a lot of us probably remember. Deployed in 2012. Landed in Gale Crater over on Mars. And this one actually had its mission extended indefinitely. The rovers have all been, well, not all of them. The rovers have mostly been very, very good at going well past their lifetime. And just last year in 2022, they sort of published a overview of accomplishments by Curiosity for sort of like a 10-year-old report. And as of today, I think, Curiosity has been active on Mars for about 3,815 days, or 10 years, 10 Earth years, I should say, 163 days since its landing on the planet. Looking for habitable environments. And of course, the idea of sending humans to Mars means that it's really good to know where we can find various rocks, minerals, and things like that we might want to use in situ to process and build buildings, to make equipment and that kind of stuff. So Mars as a destination is still pretty good. I mean, it's no Titan, but it is substantially closer, so I still recommend it. So January 19th, 2013, little shout out for the Mars Curiosity rover. Lots and lots of fun.
Absolutely.
And oh yeah?
I was just going to ask if you want me to move on to the next item.
Well, it is about halfway, so actually I think I'm just going to take a second here to remind everybody that you are, in fact, listening to York Universe. So Mars Facts Aside, those of you who know me know that I am a little bit of a fan of the planet. But this is just York Universe tonight here on Monday night, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are interested in joining in the live chat, seeing the images from the OPV crew asking questions, you can head on over to yorku.ca/science/observatory and go to the YouTube channel, or OPV. You can also find us on Twitter at YorkU Observatory, and of course also at York Universe. Tonight, you're listening to Elena and Quentin. We're discussing Mars, but we'll quickly switch topics, I'm sure. And just as a little call out, we'll go ahead and give you a couple little, I suppose, reminders just for this middle-ish part of the show. This is where we usually remind you that we actually have a Wednesday night show as well. So this is, of course, our Monday the 16th York Universe, which means that this Wednesday we are going to be following along with Rask Toronto Centre for their online speakers night, as well as doing an in-person tour. That's right, in-person tours are back at the Allan Carswell Observatory. They are not every Wednesday, so go to the website and get your Eventbrite tickets if you want them. The open shows are always posted with the tickets on the link on the main website page. So don't miss out. If it's clear, we will, of course, open up the telescope. If it's not clear or if it's raining, please be advised and remember that we cannot open the telescope if the weather is bad. We can still let you see the inside, but we can't actually open it to the sky. So we have, of course, a little bit of extra observatory news in this fancy new comet that we keep alluding to. So let me go ahead and tell you a little bit more about the comet. I think this is a good time to put the comet into the show during the halfway mark. This
absolutely.
If you haven't heard, the comet is C2022 space E3 ZTF. And this comet is making the news because it should be pretty spectacular. It's a comet that hasn't been around since 50,000 years, if I'm looking at it correctly. And it's called a green comet. So it does actually have a little bit of a green color to it, a green tinge. And this comet was actually discovered by the Zwicky Transient Facility, which is a telescope ZTF. So it's the acronym for the telescope in the name of the comet. The closest approach to the sun is January 12th, which has come and gone. So you might think the comet is getting dimmer, but the closest approach to Earth comes on February 1st. So just how bright this comet will get, we're not actually sure. So a bunch of us have been watching it as often as we can. There is, in fact, a green comet tracker online that you can access. There's a whole bunch of comet tracking sites and things like that. But as an astronomy show, I must remind you that this comet is currently not visible with the naked eye. So you do need binoculars or some kind of assistance to see the comet at the moment. So don't go out without some sort of assistance. And if you want to find out where it is in the sky, I really recommend theskylive.com. That's no spaces. Theskylive.com has a really nice site for C2022 E3, which includes things like ephemerides in case you're trying to put it into a telescope that has tracking, and finder charts, which are a big favorite of astronomers everywhere. The comet right now is in the constellation Bootes. So if you've got your Bootes, I'm probably saying that wrong.
Bootes, I believe.
Bootes, thank you.
Yeah.
Bootes, and if you've got your planisphere or some other handy, any handy planisphere will do. You can find the constellation and look with your binoculars. It's just to the edge of that constellation at the moment, and it is moving relative to the stars, so it'll change its position a little bit every night. So it's nearing its closest point to Earth, and it will get there on February 2nd. So the closest point, don't worry, it's going to be still about 44 million kilometers away. And will it become visible? We don't know.
No, we don't know yet, because last time it was anywhere near the Earth, it was before we really had the ability to certainly write it down. Now, I will say, I don't believe there doesn't seem like there's going to be much chance of it being visible in the southern hemisphere. So it's possible it may be visible in the northern hemisphere, but it's my understanding it almost certainly will not be visible in the southern hemisphere.
Again, I would recommend to check the planispheres. The comet path in the sky actually goes through the northern circumpolar stars. So the path of the comet goes through the circumpolar stars February 2nd or so. So you're talking about, when I say circumpolar, I mean stars that are near the North Pole. So things like the Big Dipper, the Little Dipper, that are quite close to the North Pole. We can see it actually traveling close to those stars. And if you're in the southern hemisphere, you won't be able to see any stars that are too close to the North Pole. They'll be blocked by the Earth. So if you're just below the equator and you wait until probably towards the end of February, it will go across Taurus, I think, if I'm reading that correctly, and you might have a chance if you've got a telescope. But by then, of course, it's going to be much dimmer. So I never say never. But it won't be at its brightest anywhere near the southern hemisphere, so that's correct.
Unfortunate, but it is what it is.
Well, if you're in the Southern Hemisphere and you do want to view, I suggest the 1-meter telescope from the Allan Carswell Observatory. We will look at putting up a live stream for you at some point. And again, there's some great finder charts out there as well. There's also some online observatories that also do viewing, so you can search around. We don't have a YouTube episode up yet, but we're working on it. All right. So comments aside, we've gone ahead and we've done a little bit of reminders for everyone. I think we have a couple really interesting this week in space and astronomy and history. So Quentin, why don't we pick one more of those for you?
All right. Okay. On January 16th, 1969, we had the first discovery of an optical pulsar. I think this is a really neat bit of trivia. And it happened today. Well, today in 1969. This is the 54th anniversary of the first discovery of an optical pulsar. So an optical pulsar is a pulsar that can be detected in the visible spectrum. And they're actually quite rare. We only know of about 6 pulsars that have a detectable visible component. Pulsars are highly magnetized neutron stars that emit beams of electromagnetic radiation out of their poles. And as they spin around, we can detect a periodic pulse of radiation each time the beam emerging from their poles sweeps past Earth, kind of like a lighthouse. The first pulsar was discovered by Jocelyn Bell in 1967, and it was emitting radio waves that were initially mistaken for interference on her radio telescope. So the word pulsar is short for pulsating radio source, and it gets its name from the radio signal detected in 1967. But on this day in 1969, a team from the Steward Observatory at the University of Arizona were able to conclusively demonstrate that they can emit in the visible spectrum as well. So the neutron star they imaged, the Crab pulsar, is the central star in the Crab Nebula, which is a remnant from a supernova that was widely seen around the world in the year 1054. We've got records of this from all sorts of different civilizations who all at the same time reported seeing this bright object in the sky, even during the day. The pulsar was first detected from its radio emissions in 1968, but the University of Arizona team were able to detect its visible signature using stroboscopic techniques a year later. The Crab pulsar actually emits radiation in a wide range of wavelengths, not just radio invisible light. For example, it's very bright in X-rays and is used as a common calibration target within X-ray astronomy.
Very cool.
Yeah, it's absolutely fascinating. It's my understanding that this would be, since it is a neutron star, this would be the remnant of the core of the star that went supernova and created the Crab Nebula that we know today.
Yeah, and to create a neutron star, this is one of the most dense objects you can create until you get to a black hole. So just a little more mass, and you'll go over and turn it into a black hole. So it is the remnant of a massive star that has ended its life, but wasn't quite massive enough to collapse down into a black hole afterwards. But it is such an interesting discovery as well, with Jocelyn Bell Burnell discovering the first pulsar, and had a bit of trouble getting this discovery out, actually. Because this was the first optical pulsar. It wasn't known that this was really a thing. They didn't know what they had. And so although she could see what it was doing, she actually had a lot of trouble getting people to believe her, and that her the scintillation that she saw, the changes that she saw, was real. And of course, once they did realize it and image it, of course it's become incredibly famous ever since. This ultra high energy source, very, very mysterious. And of course, it being a regular signal, it immediately sparked everyone's imagination, because it is a regular signal from space. It just happens to be made by a natural phenomenon. Excellent. Do you want to skip around a little bit, or shall we remind people of the conjunction first?
Oh, I really want to talk about the conjunction. Yeah, this is exciting.
Okay. So things in space. There is a lot of awesome reasons to look up, and Quentin's got a really good one for you.
Yeah, so we mentioned Comet C2020E3, and we've got another exciting event that's happening a little bit sooner than the closest approach of that comet to the Earth. On January 22nd, Venus and Saturn will be a mere 0.4 degrees apart from each other. So if you take a look at the western horizon right after sunset on January 22nd, you need to look at the horizon either right before the sun rises or right after the sun sets in order to see Venus. This is because it's on an orbit that's closer to the sun than our own orbit, so it tends to stick near the sun. This is why they call Venus the morning star or the evening star. And you will see both Venus and Saturn right next to each other, provided the weather is feeling cooperative. And both are visible with the naked eye. Venus is the brightest planet in the solar system, in fact, so it's very visible. But Saturn is certainly nothing to scoff at either. So this is very exciting. If you don't have perfectly clear weather on January 22nd, you haven't completely missed your chance to see the two objects near each other. They will be in the same vicinity of each other for several days. So my advice is, if you're out and about around sunset, take a look at the western horizon. Assuming that you've got decent weather, you might just be able to see those two planets hanging out near the horizon.
Yeah, absolutely. And as you say, it is going to be bright enough that you really should take a look, because a lot of times, with this comet, we're not sure if anyone's going to be able to see it. If your sky is even remotely clear, you will definitely be able to see this. It's going to be the brightest thing in the sky with those two sources close together. I mean, not brighter than the sun or the moon, but but it is going to be very, very, very bright. And it's going to be also very spectacular having two sources together. It might even, that low on the horizon, sort of you're going to get a lot of shifting in the atmosphere, a lot of refracting of light, because it is very, very low. So if you wait until the sun is part way down, at least it's sort of 5:30 or so. Well, at 5:30 it's a little bit higher. It is already 12 degrees in Toronto, so only 12 degrees above the horizon, which means that most telescopes won't be able to point to it if they're mounted like the 1 meter is. So we're actually going to try to point to this object during the daytime when it's a little bit brighter outside, and around 4:30 p.m. it's 15 degrees above the horizon. And at around 2:30 p.m., it's about 26 degrees above the horizon. So you can actually see it. So I wouldn't be surprised if a lot of people reported seeing this during the day as a daytime star. And then as the sun goes down, it's going to become more and more apparent just how awesome it is. So that is, you're looking at a set time for the Venus-Saturn conjunction just after the sunset. So the sun sets and the moon is right behind it, actually, which is kind of cool. You probably won't see it. It's a very thin crescent, or it will be a very thin crescent of about 2% on the 22nd. So by about 6 p.m., the moon is on the horizon. And then once you get to 6:30, Venus is at the horizon itself. So you do want to catch it earlier rather than later, which is something we don't usually recommend in astronomy.
All right. Do you want to do the last one? I think we've got time for maybe one more.
Yeah, if we're quick, I think we can. So we've definitely convinced everyone to go outside on the 22nd. Very important. Everyone should give it a try. It's going to be pretty spectacular. And just being able to recommend to something that everyone to something that's so incredibly bright and awesome. The last little event that we might just cover, I think I'm going to just go ahead and cover This Week in Space and Astronomy History, because they've been so good. And this is the week of January 19th. So that's in 3 days. The 19th is in 3 days from now. So I might as well go ahead and capture that last January 19th. Shall I do it?
Yeah, go ahead.
All right. So in case you hadn't heard, on January 19th, 2006, the New Horizons spacecraft was launched. So something that happened within Quentin's lifetime. I won't say which of the ones I got to see. So the New Horizons spacecraft is the interplanetary space probe that performed the famous flyby of Pluto. So we didn't know what the dwarf planet Pluto looked like for all of human history until this spacecraft flew by in 2015 and actually captured the first ever high detail images of the dwarf planet surface. So now we know about its adorable, bright, heart-shaped feature. This is the Tombaugh region. And after its launch from Cape Canaveral in 2006, it went past an asteroid, 123524, on its way to Jupiter. And of course, once it went past Pluto, it also flew past Arrokoth, and now it's on its way into the icy outer solar system. The New Horizons spacecraft helped us get so much information about Pluto that we didn't have, and it was kind of interesting because missions to Pluto were not really on anyone's super duper high priority list, because it's a dwarf planet, it's cold. But this mission, it got approved, it got launched, and so many new things were discovered. It just goes to show Pluto is amazing and intricate and has inverted snow. So we'll have to do a more Pluto-centric episode later on, maybe later on this month.
Absolutely.
Now we don't have time for many more Pluto ramblings, but you should definitely check out that picture. And I'll go ahead and remind everybody that you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Quentin and myself, Elena. Stay tuned, because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World and Science for the People. Thanks for tuning in to York Universe. Clear skies and have a good night.
Enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.